So what do we do in a game like this? How does the camera work, first of all? The goal of our camera for this game is to keep the player centered on the screen, or basically really is to keep the player in the same position it started relative to the edges of the screen. Really what's going to occur here is it's going to seem as if the world is moving and the player is staying in the middle of the screen. To achieve that is extremely simple. That's the simplest camera model there is. First, let me go back into game, and let's find the camera code because I can't remember where I put it. Oh, you know what? That's right. I made a change here. This is one of those cases where game doesn't care about the camera code. The camera code is completely used by the player, so only the player needs to know about it. So at the top of player.lua, you will see a line that says camera m, local camera m equals, and I require the script's camera code, which is a simple module packaged in a table, returned as part of a table, has two functions attached to that table, which by returning this gives me access to init and update. Let's find it in here. So in the init function of the player, I simply call camera init, and I pass it in the player that I have created above. I pass a reference to the player to the camera, and I'll explain what this does in a moment. And then, also in the init function, at the very bottom of it, I set up an enter frame listener. And what this enter frame listener is going to do, all right, is every frame this will execute, and whatever is inside the body, it will do that. It will call those functions. So right now, all we want it to do is call the update function on the camera. So every frame, it's going to say, camera, do your magic, make the world look the way it's supposed to, and then the rest of the game will go on for that frame. Then the next frame, it'll do another update, and so on and so forth. So every frame, we're adjusting the world.
So just for reference, interframe is also, I've heard it referred to as the game tick. Is that the other?
It is. It's what people would consider in a sense sort of like the main loop or access to the main loop. Every cycle, every tick, every frame, this gets called at the very beginning, and it allows you to do things to adjust for stuff that has happened between the end of the last frame and the beginning of this one.
Okay.
So if we look at the camera code, the initialization does nothing more. First of all, you'll notice that I called this track object because the camera can track any object in a sense. We're having it track our player object. But if you were making a game where you really wanted to keep track of like a missile or something, like you fired a missile and then you wanted the camera to follow the missile to where it went, or like Angry Birds, where you really want the camera to track the thing that you're shooting, which is the bird. So you would have your camera track that object. So I call it track object, the object that I am tracking. So the initialization is simply to take the track object and store the initial position of that object. Because what we're going to do is say every frame we're going to say, we'll execute this update code, and we'll say current position minus the last position for X, current position Y minus the last position for Y, so dx, dy, which is the delta X, the delta Y, the change in X, the change in Y, so that's what that means. Then we will say, okay, we got that information, now let's make the last X and Y equal to the current X and Y, so that the next time around we have those values. And then let's do something with it. And to do something with it, this is why I love this camera. It's so simple. You'll recall that last week we talked about the layering system. In fact, let me just bring it up so it's really clear. Our layering system has an underlay, a world, and an overlay. Now the world layer contains 3 more layers, content 1, 2, and 3. where 3 is on top, 2 is in the middle, and 1 is below. And world contains them all. Now, the reason we had 3 layers was to get nice layering effect, make it easy for us to create our hallway, so that this light blue here was always on top of the shaded part and over the background track, and then this blue bit here is in the underlay, which is below world. So this is for layering. But another reason I did this is because I knew I was going to make a camera. So in the camera code, because everything is inside of world, to keep the world centered around an object within those groups is as simple as calculating the distance that the object moved from frame to frame and subtracting that from the world's position. So in a sense, if the player moves from here to here, all we're going to do is we're going to take everything, the entire world, and we're going to slide it back the same amount. So if I've uncommented all the code correctly, hopefully I have, I'm going to press return, and what's going to happen is, well, I'll just do it. Now it's functioning correctly.
Nice.
Easy peasy lemon squeezy. Oh, but now we've run into our next problem.
Bridge out.
I paused the simulator. We're out of hallway. But you know what? We're out of time, so I think next week we should talk about particles and how to generate more hallway.
So it's literally a cliffhanger.
It's literally a cliffhanger.
Well, that's fantastic. That is fantastic, and I would encourage everybody, to go get the project and experiment with what Ed's got there, and not just to follow along certainly, but spend some time picking apart what he's got and make it your own. Mess with it. Mess with the camera code. Get a good feel for what happens if I put a spin on that, right? Make the world go woo. I mean, there was one part in the beginning where you made the width of the hallway. I think you went from 100 to like 200, and there was that space, that little space where you can see it here. The hallway was only this big, and it looked like which gave it the illusion that it was far away. Especially when you went to the 200, which made everything feel bigger and closer. So if you did, started the game out with like a small hallway and then transitioned it to a bigger hallway, it would seem like you were flying into the scene. I don't know. That was one of the.
No, it gave you the wrong sense. Yeah, I mean it felt when it was a narrow hallway, it felt all wrong. Like one of the things you're going to notice about this when people play it, 75 obviously as a velocity is way, way, way too easy.
Yeah, it was one of the first things that I thought was like, wow, this looks a lot easier than the original game. But I also took
you recall, I'm not showing you the code anymore. Oh man, I'm talking to my screen like you can see my code. Sorry.
But I'm sure that's probably that's part of the educational piece is we need to be able to make sure that we can play the thing. Right.
Initially, I made this. People will recall if they look back in the video. Player line 22, I set it to 75. I wanted it to be slow because I'm demoing this. If the thing is zipping along, I'm going to go, oh, I'm going to be making mistakes as I'm trying to explain what's going on. But closer to the actual game speed is around 200. People will have to adjust.
Yeah, which also means that you could increment that over time and make it harder and harder and harder.
Right, absolutely. We talked about this last week, which was the Me Too plussing. You could certainly do some things with this. I encourage people not to simply take the end code and sell it in the store, but to do something new and interesting with it, please.
Yeah, you could even after you've passed two or three corners at a time, you could increase the radius of the player, right, making it harder to.
Right. See.
Or decrease the width of the hallway and increase the width of the player or the radius of the player.
Although I would say that decreasing the width of the hallway, challenging.
Oh yeah.
Yeah. Because this hallway code is not set up. Because basically you're drawing your hallway.
So not challenging necessarily for the player, but challenging in terms of code.
Yeah. Actually, no, you could do it though, because if you pay attention here, the hallways are not always the same. See, there I go. Can't play it set. I cannot play at 200, obviously.
The camera is really cool. I'm going to use that one.
Yeah.
Yeah, this is the thing. People are like, how do I do a camera? How do I do a camera? Man, the basic camera, which is what this is like, the fixed camera, the static camera, I don't know, there's a lot of different names for it. It's really straightforward. Now, I will warn you, one thing about this camera code, if you're using transition 2 to move the object, camera code doesn't work. There's some kind of bug in Corona, or I wouldn't call it a bug. There is a sequence of execution in Corona such that if you don't set it up right, it doesn't work. The transition, it feels lurchy. It doesn't feel smooth, but it works perfectly with physics.
Well, didn't we kind of discuss that before? That transition is sort of a start and an end point sort of mechanism,
It
whereas
continues. It's a continuous execution, even as the frame. I think the problem is that when you call your function, you get whatever value it is. So it even changes post frame.
so it's a timing issue.
It gives a weird sense, but there is a solution to it. People who want to know can ask the question. Perhaps I'll answer. There's a way to solve it. I showed previously how to solve this when we were looking at the physics code for the shadows by what was the gentleman's name?
Renee I.
Renee?
Yeah.
Yeah, it was Renee.
Pyropixel. Renee I at Pyropixel.
Ran into that. He called it the. I can't remember what he called it, but I told him what the answer was, which was to grab the value at the beginning of the frame and use that value from then on for your calculations instead of continuously grabbing it directly out of the object.
Okay. Well, that's good. Yeah, if you have that question, ask, and it'll point you in the right direction, hopefully. And so let's talk about what we're going to talk about next time.
Yes. So next time, for sure, we will add continuous hallway generation and particles.
Oh, sweet. And
that'll be it, because the next segment after that is interfaces, and I don't want to mix the two.
Okay. I was going to say, I feel like we're getting a solid piece of gameplay pretty quickly.
Yeah, I may also add the code to simply restart the game when you fail. So we'll get to the point where you're just continuously being able to play it.
Okay.
But we still have to do the bit where we count how far we've gotten down the hallway. And then once we do that, it's time to strap on Composer and add the other interfaces. We're done.
Oh, cool. All right.
We got it all.
So there you go. So your homework in the meantime then is to go download Ed's code, which a link will be in the show notes, and to experiment. I want you to go in and change values. Look at his code, look how it's structured. He's walked you through everything. Go in and manipulate the values that are there and see what happens. It's the best way to understand and to kind of own and internalize the code. So go do that, and then we'll be back here next Monday at 12 p.m. Pacific to talk all about mobile app development using Corona SDK. Until then, have a great week and happy coding.
Adios.